Hey everyone, it's Miss Gubrood. We're back with more converting fractions from improper fractions to mixed numbers, or from mixed numbers to improper fraction, as we call that vice versa, when it's kind of back and forth, both opposites. So what you need for today is you need the sheet that looks like this. It's either in your Google Classroom or your teacher has handed it to you. So please find this sheet and look for the side that matches the picture I have to get us started. So it's got 3 circles in number 1. So make sure you're on this side of the paper. When you have that, pause and get that. And when you have it, come on back. All right, so you can see the directions say use numbers to write the fractions shown in the diagram, but I changed the directions a little bit, and you notice that written up at the top. There's 2 categories. I want you to identify what's pictured, and then also I want you to convert it if you can. So convert it if it's a mixed number, convert it to an improper fraction. If it's an improper fraction, convert it to a mixed number. And what do you do if it's just a plain fraction? Then you don't convert it. You just leave it and X that section out. We'll practice that together. So take a look at the picture. You're going to look at the picture and say, what's being shown here? Well, I see they're all the 3 the same size, so I know those must be the wholes. And I see there's 1 complete whole, 2 complete wholes, and then this one is cut into parts. So I know my answer is going to have 2 wholes, and then I have to figure out what fractional part this is. Remember, the bottom number tells how many it's cut into. 1, 2, 3, 4, 5. So there's 5 pieces that it's cut into. That's the denominator. And then the numerator tells us how many of those 5 are we talking about? How many are we selecting? 1, 2. So that's the numerator. So this picture is showing 2 wholes and 2 out of 5 of another whole. So 2 and 2/5. Now, the next step we need to do is convert it. I want you to actually take on your paper, right on the paper, I want you to take your pencil or your pen or your marker and literally cut up the pieces differently to convert it to an improper fraction. What that looks like is on your paper, you're going to use your pen and cut up these 2 wholes. And I'm going to do that here so you can see it more easily here. So I'm going to take a different color, maybe orange, that might be easy to see. If this one is cut into 5, I know the other 2 wholes also have to be cut into 5. That's that. Whoops, that's not a very good marker. That denominator tells me that the wholes are cut into 5 pieces. So I need to cut them into 5. Now 5's tricky, especially with circles, but do your best. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, it doesn't have to be absolutely perfect. No worries. We know that we're trying to get it as close as we can. Now that you've recut the shapes, please over here in the converted, tell us what it is converted to if it's all an improper fraction, if it's all the parts. Well, we know there's 1, 2, 3, 4, 5 fifths there. 6, 7, 8, 9. Now we've gotten to 10 fifths, 11, 12. So there are 12 pieces the size of fifths. We want to check and make sure it's an improper fraction. Is the top number bigger and the bottom number smaller? Does it describe more than a whole thing? Yes, we're in good shape. Now, I didn't put this on the directions, but I also want you to try something. I want you to try a method that our friend Adelmer, shout out to him, by the way, showed us in class the other day. If you don't have him in class, you maybe didn't see it, that's okay. We're going to talk about that you can convert these numbers numerically, just using operational signs, adding, subtracting, multiplying, dividing, and the numbers. So let's see if you can do that. So here's how it goes. You take the whole number, 2, and the 5, and you multiply those together because we have 2 groups of 5. Check that out. There's one group of 5. There's the second group of 5. So 2 groups of 5. What operation is groups of. I hope you said times means. I hope you said times means groups of. So 2 groups of 5. So we put a multiplication sign right in there. Times means groups of. 2 groups of 5. 2 groups of 5 is 10. Now, we still have these other 2/5 to do, so we can add in the 2/5. So we do 2 times 5 is 10. There's those 10 right there, 5, 10, plus 2 more, 12, equals 12/5. So please give this a try. Follow along with me and write that on your paper. Give that a try. Let's try another one. All right, I'm on the same side of the paper, number 4. Now, unfortunately, I realized after I made photocopies of these that there aren't any numbers on your paper, but here's number 1, and if you think of 2, 3, 4. So I'm on this one right here, the one that matches. So take a look at that one. So again, we're going to start by looking at the picture and determining what is the fraction that's being shown. Well, there's only one whole. We don't have any actual holes, but we just have one, and then we only have a part of that one. So there's no holes to write. There's only 1, 2, 3 pieces chosen out of 4. So there's 4 pieces. That's the denominator. When the whole is cut into pieces, the number is cut into, that's the denominator. And 1, 2, 3, we're selecting 3 pieces of it. So that's the numerator. So this picture shows 3 out of 4, 3/4. Now, what if we convert it? Well, I hope you're saying, wait a minute, Ms. Gubrud, aren't we converting improper fractions to mixed numbers or mixed numbers to improper fractions? This is just a regular proper fraction. That's just regular. Top number is smaller than the bottom number. It's just a fraction. The answer is yes. Don't let that trick you. We're not converting that to anything. So you just X that out. And then what about the numerical representation? Nothing. We're not converting it. So there's nothing there either. That one was pretty easy. Let's try another one. All right, I'm on the same page. This is number 3. So we did the top one. We skipped 2 and 3. We did number 4. We're coming back to number 3. So take a look, make sure your picture matches this. Now, this is something different. Notice that they're showing some that we're selecting everything, but we also notice that all of them are cut into pieces. If they're all cut into pieces, what is that a picture of? I hope you're saying, well, I see 2 holes there. We're selecting the whole thing, but they're also cut into 4ths. So I think this picture shows an improper fraction just because it's already all cut up. So pause, see if you can figure out what the improper fraction that's being shown here is, and come back and see if we agree. All right. Do you agree with what my answer is? Each of these pieces, each of these holes is cut into 4 sections. So 4 has to be the denominator. Each one is cut into 4. But how many pieces, the size of 4ths, how many of those do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 pieces cut into the size of 4ths. So we've got 11/4. How'd you do? Now we need to convert that because we're converting improper fractions to mixed numbers and vice versa. So we can see that this is an improper fraction. The top number is bigger than the bottom number. We might be able to see the conversion just by looking. We might be able to see the mixed number just by looking at our picture. You might notice, how many holes do we have? 1 hole, 2 holes. So you might just be able to see that and notice that there are 2 holes. What about anything that's left over? Well, what's left over is 3 out of 4 pieces. So the conversion is 2 3/4. Now stay with us because we want to find out there's a way to do that numerically. So let's see if we can figure this out. It's a different way to do it than we changed mixed numbers to improper fractions. Here, we're starting with 11/4. This time we have to divide, or we have to think of multiplication going forward with something missing. So you would say 11 divided by 4 is how much? Because we have 11 and we're dividing them by groups of 4. So we could say 11 pieces divided by groups of 4. Well, when we take 11 divided by groups of 4, there's one group of 4, two groups of 4. So we could do 11 divided by 4 equals 2. And how many is left over? There's 3 left over. And so those 3 are 3 out of 4 pieces. So is 3 out of 4 pieces. So 2 3/4. If it's easier for you to think of multiplication going forward, you could say, how many 4s? And again, this is kind of division, but remember, division and multiplication kind of go back and forth. How many 4s can I take out of 11? Again, repeatedly taking things out, that's division. But if it helps you think, 4 times what gives me close to 11, not going over 11, but close to 11, 4 times what? That can be a way to change it into multiplication if your multiplication facts are stronger. So how many times can I take 4 out of 11? I can take it out once, that's 4. I can take it out twice, that's 8. So I took it out twice, that was 8. And what's left over to get from 8 to 11? 8, 9, 10, 11. There's 3 left. And it's 3 out of 4. So it's repeatedly taking out the denominator out of the numerator over and over again until you get super close, and then you just have maybe a fraction left. So on your paper, front and back, convert improper to mixed, convert mixed to improper. See if you can try the numerical way on those. Don't get tricked on the ones that are just fractions. If they're just fractions, don't have to do the rest. Just identify it as a regular fraction and everything else is crossed out. Good luck. See you next time.